There we go. Now I'm on. Okay. Okay, the energy provided from the food we eat is measured in calories. Calories is spelled with a capital C. Actually refers to kilocalories. A calorie is the amount of energy that is required to raise the temperature of 1 gram of water 1 degree Celsius. A kilocalorie, or 1,000 calories, is the amount of energy that is required to raise the temperature of 1 kilogram of water 1 degree Celsius. Calories are needed for activities, growth, and basic body functions. The recommended daily calories needed vary with age, sex, body makeup, and activity. Generally, children need more calories per body weight than adults because children are still growing. Boys need more calories than girls because boys have more muscle tissue to keep healthy. Because more energy is used, an active individual such as an athlete or manual laborer needs more calories than an inactive person. So right here we have the box calories needed based on age. So you guys would fall into the 16, 17, possibly even 18, but it doesn't show 18-year-olds. So you would need, for 16-year-old girls, you need to eat about 2,250 calories to 2,800 calories a day. 16-year-old guys, 2,700 to 4,000 calories per day. 17-year-olds, girls, 2,250 to 2,800. And 17-year-old boys, 2,800 to 4,000 calories. Again, that just depends on how active you are. Okay. Calories based on occupation. An athlete needs about 4,000 calories. A manual laborer needs 4,000 to 5,000. If you're sitting at a desk working, a guy needs 3,000 calories. A woman needs 2,200 calories. And then if you're sitting around doing nothing, you only need about 1,900 calories to live. Okay? Flip the page. Sugar consumption. The average person in 1700s consumed about 4 pounds of sugar per year. In the 1990s, the average person consumed 150 pounds of sugar per year. Yes. Sugar content of select foods. So bottle salad dressing has 25 to 30% sugar. Canned fruit and heavy syrup is 18%. Ketchup is 29%. Chocolate is 51%. Non-dairy creamer substitutes is 60 to 65%. Powdered gelatin mix is 82%. Ready-to-eat breakfast cereal is 57%, and yogurt with fruit is 14%. We have a chart here with calories and selected foods. And then that's it for this section. You guys are going to be doing homework, page 180. And you're going to do 1 through 22. 1 through 22 odd. 1 through 22 odd. That gives you 11 problems of homework for tonight. Okay? So you guys can go ahead and get started on that. Again, we're going to have a quiz at the end of the week. Tomorrow I will actually give you those sections to study. The quiz is going to be on Friday. Test will be next week, I believe. All right?
Uh, that's working. But anyway, 10.39 on page number 70. Okay, page number 70. Hello, testing, testing. Oh, right there. Okay. Hopefully, those of you on distant learners can hear me. Please let me know if you can or cannot, and then comment that you are present in this class. Okay, so we are on page number 70, 10.39, talking about mood. Okay, so the mood of a verb is a grammatical form that indicates the state of mind or the manner in which a statement is made. Hey, Mr. S. Okay. Okay, so we know that there are different kinds of tenses with our verbs. There are three kinds of moods in English. So number one, the indicative mood. Number two, the imperative mood. And then the number three, the subjunctive mood. Okay, so let's go ahead and look at the differences between those. The indicative mood states a fact or asks a question. Okay, this is the mood used most of the time. He always gives his tithe. Do you always give your tithe? So it's stating facts, asking questions. That's indicative mood. Okay, facts or questions, indicative. Okay, then there's number two, the imperative mood. This one's kind of simple. It gives a command or makes a request. We already know what an imperative sentence is. That's a type of sentence that makes a request or gives a command. Same thing with the mood. Imperative moods, they give you commands or requests, okay? Moods just have to deal with the verbs, okay? And then subjunctive, this mood expresses an action or a condition as a conception of the mind rather than as reality, okay? So this is basically, think of hypothetical, okay? If I were you, I would keep my head down. Obviously, I'm not you. So this is kind of a concept of the mind, and it's not actually reality. That's subjunctive. Same thing. I wish you were going with us. You're not actually going with us, but I wish you were. This is kind of subjunctive. It's a concept of the mind, okay, not reality. That's subjunctive, okay? 10.43. The subjunctive mood has only a few forms which differ from the indicative. Okay, so indicative mood, they state a fact and ask a question. Subjunctive mood, this is how it differs from indicative. Okay, the present subjunctive form of the word be, which is a verb, is invariably be in all persons, singular and plural. Okay, so be is normally be, whether it's singular or plural subject. Okay, if there's one or two, the form of the word be is normally the same. Okay, and the past subjunctive form of be is invariably were in all persons, singular and plural. This is basically saying the past of be is were. Okay, for all other verbs, the only subjunctive form that is different from the indicative is the third person singular present tense, which drops the S or the ES and becomes like all other forms. So this would be the only difference between subjunctive and indicative. He has become to he have, becomes he have, he does becomes he do, and he sees becomes he see, etc. These are just the differences between those. Okay, so look at your chart. Subjunctive mood, this is kind of a conception of the mind or rather than a reality. Okay, so the present tense form of the word be. Okay, first person, if it's singular, if I be, plural is we be. Second would be you be in whatever form of the be word it is. Okay, past tense of be, if I were, if you were, he or she, if they were, we were, you were, they were. Those are all past tense of the be form. Present tense of the word have. I have, you have, she have, they have, all of those. So if the word is, if you notice the word if is in the parentheses, so this would be, this would be, examples of like clauses. So like if I would have done this or if I had done this, okay? That's why the word if is there. It's kind of hypothetical. Then the present tense of do, if I do, you do, he, she, it, they do, we do, all of those, okay? All the other tense forms of the word be, have, or do are exactly the same in the subjunctive as they are in the indicative. Okay, so you don't really have to change that much. Okay, look at 10.44. The following are some common uses of subjunctive moods. Use the subjunctive mood, we are on letter A, use subjunctive mood in dependent clauses to express a condition that is contrary to a fact, which is something that is not or could not be true. Such clauses are often introduced by the word if. Okay, so this is your example. If I were you, obviously I'm not you. If he were properly disciplined, he would behave. Obviously, he is not properly disciplined. Therefore, this would be subjunctive. Okay? Use the subjunctive mood to express a statement following as if or as though. She looked as if she were going to cry. Okay, that's why you don't use the word she was. In normal cases, obviously was goes with the word she. But if this is subjunctive, then you would use the word were. Okay, subjunctive is something that is hypothetical. Okay, it's like a concept that isn't reality. So that's why people say, if I were you, then I would listen to good advice. People don't say, if I was you. Okay. So these are your rules with subjunctive mood. You want to use the past forms, okay? Subjunctive mood to express complete thoughts with the words if and then as if or as though. Okay, letter C, use the subjunctive mood in a dependent clause after an independent clause that expresses a wish, a request, or a requirement, okay? So he says, I wish that he were able to go, okay? There's a wish there, so that's why you would use a subjunctive mood of the verb in the independent clause, or in the dependent clause after the independent clause, okay? So if you guys remember, it's a little while ago, dependent clauses are clauses that cannot stand on their own. So in this case, that he were able to go is dependent, okay? So you would use subjunctive mood in the dependent clause after an independent clause, which in this case would be I wish, okay, if it is expressing a wish, a request, or a requirement. Okay, look at your second example. The senator urgently requested that the bill be rejected. Okay, that the bill be rejected is your dependent clause, dependent upon the independent clause, the senator urgently requested, right? So look at my form or my verb of the word be. Okay, normally I wouldn't say bill be rejected. I would say the bill was rejected, right? But in this case, I would use subjunctive mood, and we know that subjunctive mood and indicative mood are all the same when it comes to stuff like this. So I would use the word be. That's what our chart was with the form be in subjunctive mood on page number 71. That's why if it's singular, it said I be, you be, okay, instead of I am or you are. That's why it's all in subjunctive mood and it's all the same. So that's why I'm using the word be in this dependent clause. Does that make sense to everybody? Okay, look at your third example. The teacher insists that David improve his writing, okay? Normally, with a singular subject, I would say David improves, right? Okay, but in this case, I need a subjunctive mood. Therefore, my verb of improve is the same as it would be for any other plural subject, okay? This is if there is a dependent clause after an independent clause that is making a request, making a wish, or a requirement, okay? Then letter D, use subjunctive mood in a dependent clause that states a parliamentary motion or a legal judgment. Okay, look at your example. I move that the meeting be adjourned until tomorrow. Okay, legal judgment, parliamentary motion. It's basically saying that you're doing some kind of legal declaring thing. I move that the meeting be adjourned, okay, until tomorrow. The court's decision is that the golf course be sold to the highest bidder, okay? Obviously, B in any other case wouldn't be proper there, but in subjunctive mood, that's when you would just use the form be. Okay, let's practice these. Go to page number 24 in your workbook. Exercise 47. Okay, page 24, exercise 47. Okay, we didn't go over voice yet, did we? On exercise number, on page number 23, active and passive. Okay, we'll go over that tomorrow, but let's practice mood, okay? Identify the mood of the italicized verbs by writing above them indicative, imperative, or subjunctive, okay? So if you guys need to look for a reference, go to page number 71 in your workbook, or your handbook, so that you can look at the differences between indicative, imperative, and subjunctive, okay? Look at number 1, okay? I demand that he pay for the window that he has broken, okay? Look at the first verb. What's italicized, class? Demand, okay? So I need to look at the mood of the word demand, okay? Is it stating a fact or asking a question? Is it giving a command? Or is it expressing an action or condition as a concept, a conception of the mind rather than as a reality? What do you think that one would be? Demand. What is it? No, it is not imperative. Okay, I can see why you get that one confused as imperative, but imperative is literally giving an advice or giving a demand or request. Okay, so such as close the door, take this to the office is a direct command. Okay, so in this case, this is indicative, because it's asking a question or, stating a fact that he needs to pay for the window that he has broken. Okay, it's not giving, hey, you need to pay for this. It's just kind of the verb there, stating the fact that he needs to pay for the window that he's broken. Does that make sense? So demand is indicative. Okay, let's look at pay. All right, so we know that it is in a dependent clause that he pay for the window. So which mood do we use in a dependent clause? We just went over that one. That was the last one. Okay, subjunctive. Okay, so in any ordinary case, I would say he pays for the window, right? Because pays would be a plural or a singular verb. But in this case, since it's within a dependent clause, that he pay for the window, our rule for subjunctive mood is that all the verbs would be the same for both singular and plural, which is why we still have a plural verb, right, in subjunctive mood. Okay, so make sure you're watching for those. Okay, and the last one, has broken. Who knows this one? Who can guess? It is indicative, okay? It's not giving a command or making a request, okay? This is just stating a fact. He has broken. Good. So demand is indicative, pay is subjunctive, has broken is indicative, okay? Go ahead and work on number 2. Number 2, be quiet and listen to what I have to say. What is be? What is listen? And then have. Who can raise their hand and tell me what be is? Be quiet. What is it? I'm sorry, I can hear you. This one isn't subjunctive, okay? Read the whole sentence. It is imperative. It's telling us to be quiet and listen. So that is imperative. This is actually giving a command or making a request. Okay? So make sure you guys are looking for these. That's the differences between the first indicative demand in the first sentence. Demand is indicative because it's just stating a fact that I demand that he pay for the window he has broken, okay? He's not saying pay for the window, right? So that's why demand is indicative. But in number 2, it's actually saying be quiet and listen. That's why be and listen are both imperative, okay? And then have is indicative, okay? This is making a fact or asking a question, okay? Number 3, if gasoline were not so expensive, we could afford to travel farther on our vacation. Okay, what is the word were? Who knows? This one is subjunctive, okay? You can spot subjunctive words or subjunctive verbs if you look at the verb and say, hey, if the subject is singular, but my verb is plural, and it makes sense, maybe it's a subjunctive verb, because remember, the verbs are all the same, whether singular or plural, in subjunctive mood. Okay? Number 4, the letter asked that I come to the West Coast as soon as possible. Okay? What is my verb asked? What kind of mood is asked? Okay, why would it be subjunctive? Is it a conception of the mind rather than reality? Yes or no? No, it's not. Okay? So is this giving a command? Is the letter saying, come to the West Coast, or is this kind of stating a fact that the letter of what the letter said? It is indicative, okay? It is stating a fact of what the letter said. Okay, so in mood, if it's not specifically asking you to do something or telling you to do something, it's not imperative. Okay? It would be subjunctive if it wasn't reality. Okay? Anything else, if it was reality, if it's stating a fact, asking a question, it's all indicative. Okay? So that would be indicative. Asked is indicative. Okay? The letter asks that I come to the West Coast as soon as possible. Okay, what does the word come? Okay, notice how it's in a dependent clause. What word or what mood would I use within a dependent clause? Good. Come is subjunctive. Good. Okay, I know these are a little confusing, but once you know the differences between all 3 of them, they should be easier to spot. Okay? Then the last one, children, obey your parents in the Lord. Okay, what is the word obey? This is imperative. It's making a request or giving a command to obey. Good. Okay? For this is right. This is indicative. Good. Okay? It's not giving a request. The word is. Okay? It's not some concept of the mind rather than reality. So it's stating a fact that it is right. Therefore, it is indicative. Okay? We'll practice those a few more as we move on through this week. Yes. Number 2, for listen, it's imperative. Okay? Because it's telling you to listen. Be and listen were both imperative. Okay? So we just did tonight's homework. Tonight's homework was exercise 47. So good deal. And then we will work on voice tomorrow as we prepare for our test next week on, let me see, Wednesday, I believe. Yes, on Wednesday. Okay? Are there any questions about any of it? Awesome. Okay? So tonight, 7 through 12, 2 times for your vocab. So let's go ahead and pull that out really quickly. If you haven't already, please turn in your homework from last night, which was your vocab from list number 5, numbers 1 through 6, 2 times. For those of you online who haven't sent in your vocab yet, please take a picture of it or scan it and then email it to me or text it to me so that I know you've done it. And then tonight is number 7 through 12. So let's go over number 7 through 12 in list number 5. Okay? I'm going to read the vocab word. Please read out the definition nice and loud. Okay, look at number 7. This one is epithet. Okay. Thanks, Jamie. Epithet is a name or a title used to describe or characterize a person or a thing. What is an idiosyncrasy? Okay, idiosyncrasies are basically temperaments or mannerisms to somebody. Okay, number 9, panacea. Supposed remedy for all diseases or ills. What is plethora? Excess, superabundance. What is a pseudonym? Good. A fictitious name as one assumed by an author. And then number 12, sporadic. Good. Occurring in occasional or isolated instances. So go ahead and write 7 through 12 tonight for homework. If you haven't done it already, you can go ahead and work on that right now so you don't have to take it home. But for those of you online, please send in last night's homework, vocab list 6, numbers 1 through 6 2 times. Okay? Are there any questions about the homework? Oh, and then literature, you need to read pages 101 to 104 so that we can discuss that tomorrow. Okay?
All right, welcome to Algebra 2. We're going to get started. We are on page 159 of your text, page 159 of your textbook. Couple quick things. First of all, quiz 11 is Friday, January the 8th. So please make sure you, that's this Friday, so make sure you guys are studying for quiz 11, which is 4.1 and 4.2. So make sure you have that in mind. Obviously, Google Classroom will continue to have your assignments on it, and let's move on. 4.22 variable linear equations. An equation and its graph give mathematicians needed information about how one variable's change affects the other variable. As seen in the last section, the slope of a line can show whether the variables have a positive or negative association in the equation. If a line has positive slope, then as one variable increases, the other also increases. If a line has negative slope, as one variable increases, the other decreases. This section will develop several graphing strategies as well as several forms for two variable linear equations. A linear equation has collinear solutions, which means they lie in a straight line. Co means with, linear means line, so with line. Developing a list of corresponding x and y coordinates lists the order of pairs that make up the straight line. While only 2 points are necessary to draw a line, a third point ensures that the correct straight line is being graphed. Check that each point along the line is a valid solution by substituting into the original linear equation, at least enough to be fairly certain that you got it right. Okay. So, first method is intercepts. The point at which the line crosses the x-axis is an intercept. At an intercept, one of the coordinates of the ordered pair is 0. Let me change the size. There we go. All right. The x-intercept is a point at which the line crosses the x-axis. For an x-intercept, y equals 0 because the point is neither above or below the x-axis. For the same concept applies to the y-intercept, x equals 0 because the intercept is 0 units from the y-axis. To find the x-intercept of an equation, substitute 0 for y, and to find the y-intercept, substitute 0 for x. Solve for the remaining variable. After the intercepts are plotted on the Cartesian plane, a line can be drawn through the 2 points. Plotting a third point is recommended to ensure that the intercepts are correct, but is not necessary. And usually if you're doing intercepts, I don't. All right, so let's graph y is equal to 2x plus 8 using the intercept. So first of all, to solve for the x-intercept, I'm going to say that y is 0, okay, because that's where it's going to intercept the x-axis, okay, hence the name. So we have 0 equals 2x plus 8. Subtract 8 from both sides. We get 2x. And divide both sides by 2. We get negative 4 equals x. And so we get negative 4, 0 for our x-intercept. Keep in mind that an intercept is a point, so you should put both parts of the point. It is incorrect to say that the x-intercept is negative 4. Okay? That's the first one. Then we have the y-intercept, where x is 0. It's always the opposite one. So we have y is equal to 2 times 0 plus 8. Well, in that case, it's 8. Okay? 2 times 0 is 0, so that makes things real easy. So again, we have to say it's 0, 8, because it's a point. It's not a value, okay, as it were. So then what we can do is we can take that and plot it on our graph. So let's say we have our Cartesian plane here, okay? And so we have our x value, our y value. This is, of course, infinite in all directions. And so the first one I'm going to plot is negative 4 is 0, because it's where the x-intercept. So I'm going to go back 4. I have to remember that you guys can't see that. So I'm starting at the origin. I'm going to go 1, 2, 3, 4, plot this point. Really wish I knew all the keyboard shortcuts, but anyway. And then we have 0, 8 here. So we're going to start at 0 and go up 1, 2, 3, 4, 5, 6, 7. Of course, it's 1 off the grid, because why wouldn't it be? All right, I'm just going to move the page rather than fix it. All right, there we go. All right, so to get to 8, we have 1, 2, 3, 4, 5, 6, 7, 8. So right here is where that point is, and then we're going to connect the dots. Okay, you want to use your ruler and go past. Whoops. I am stuck doing this method because computer. All right, so that is the correct line then for this equation, okay? Then I should finish it off. Try to get, that's as good as I'm going to get. I should finish it off with arrows. Just believe me that there's an arrow on the other side. And we put the original equation, y equals 2x plus 8, on the graph itself to make it very clear. We have to label our graph. Now, for lines that pass through the origin, the x and y intercepts are the same, and you will need to plot a second point. At this point, you're better off doing a table of values rather than going intercepts. Once you hit that it's 0, 0, well, that's great, that's one of your points, but then just find another point. That's basically what you're doing. So you pick a value for x. In the example B there, they pick the value 1, and they find out that the next point would be 1, 5. Okay, and plot those 2 points, you can draw your line. All right, I'm not going to go through that, though. Graphing with slope. Page 161. Through a given point, only one line can be drawn with a given slope. To find this line, we apply the definition of slope to determine how many units to move in each direction from the point. For example, suppose that the given point is the origin and the slope is 2. First, realize that the slope is a ratio and essentially 2 over 1. Thus, going up 2 and right 1 indicates another point on the line. Notice the slope can be written as -2, -1, which also simplifies to 2. This means we can go down and left to indicate a point, another point on the same line. The key thing here is that to keep it positive, you have to do double negative. Or if you're trying to stay negative, you're only allowed to go negative in one direction. So you can go down or left, but not both. Got to get used to teaching after basically not talking for like 3 weeks. So, all right. So let's look at how to graph this way. So I am told to graph a line using the given point and slope. When we are given, this is example C, I'm given the point 0, -2, and the slope m equals -4. And so I'm going to go ahead and create our Cartesian plane. And just trust me when I say that's on the graph, or on the grid. All right. We have 0, -2. That means I'm going to start here at 0, -2. Okay, pretty straightforward, right? Well, we have 0, -2, then our slope is -4. Now, again, because I want to keep it negative, I can either go down 4 into the right or up 4 into the left. Because this is essentially -4 over 1. Okay? But either one can be negative as long as I don't try to make both negative, because that would accidentally make a positive. So, remember this means rise over run, so I'm going to go down 4, 1, 2, 3, 4, to the right 1, and we plot that point. Or I can go up 4, 1, 2, 3, 4, and left 1 to account for that negative. Either way, we get the same line. Okay? And I normally recommend either doing one of each or 2 in the same direction to kind of make sure that you're doing things correctly. So again, keep in mind that left is negative and down is negative. If you have 2 negatives, you make a positive. So as long as you don't do that, you'll be fine. So we're going to go ahead and connect the points. And close enough. All right, put our arrows, and then we put down, well, we don't have an equation for this one, so that's it. All right, let's look at example D. In example D, notice that vertical lines are undefined. So we have -3, 1, and we have n is undefined. Okay? Basically what this means is that we had some number over 0, and you can't do that. We consider that to be undefined. If 0 is over some number, provided that's not also 0, then that's fine. It's just the answer is 0. If I have 0 halves of something, I still have 0. Okay? So just kind of mentioning that difference there. A lot of people will see 0 in a fraction and then go, oh, well, it's undefined. Not necessarily. It's only if it's on the bottom. All right, so this is undefined. And so what's going to happen then? Okay, you guys need to like wait until class, not when I'm teaching other classes. Thank you. All right. All right, so setting up our grid, X and Y, and I'm going to switch colors to make it more obvious which one's which. We're going to go to -3, 1, so right here. But I have an undefined slope, and I'm told it's a vertical line right off the bat. So really, anything on this vertical line here is going to work. Okay? So that's going to be my vertical line where simply x equals -3 is the equation, if you will. Oops. Okay? X equals -3 is that equation. So that's kind of what happens there. It's an undefined slope because you're not sloping. It's just wall. Okay? This does not have a slope. Okay? That's just the wall. I'm not going to climb it. Okay? It might be really hard before it's sheer vertical like this, but you could still technically kind of try to climb it. Okay? But once it's vertical, at that point, you're rock climbing. Okay? So that's the idea. Zero slope is when it's horizontal line, when you're just walking on a flat surface or something like that. As shown there in part B. I'm not going to go through and regraph it. You guys can see it there on page 162. But you have the horizontal line where slope is 0. And I'll graph it on the same one in red. I'm given the 0.42, so 1, 2, 3, 4, 1, 2, so right here. And then when we graph that line, it looks like this, where y, oh, rats, undo. Y equals 2 would be our equation there. In this case, this has a 0 slope because there's no incline at all. Okay, and so that's really the idea of what we're looking at here. Table A reminds us of the forms of linear equations. We have the standard form where ax plus by equals c. A horizontal line would be y equals something. A vertical line would be x equals something. Then, two things that you should remember from Algebra 1 are slope-intercept form, where y equals mx plus b, and the point-slope form, where y minus y1 equals m times x minus x1, which we use to get to slope-intercept form. I'm going to review both those here briefly. Okay, I will deal with that later. All right, so all right, I'm not going to worry about that, but those are your forms of linear equations. That's what you need to know. You can see, you can anticipate whether you'd have a horizontal or vertical line. They show you that on the top of page 163. Let's go ahead and go straight to slope-intercept form, though, on page 163 and deal with this. All right, so we have example E, and we are given the equation negative 3x plus 2y equals negative 4. Okay, one of the easiest ways to graph, in my opinion, is to go through and solve for y and then go from there. Okay, so that's what we're going to do. So we have 2y equals 3x minus 4. I always put the x term in front because that lines everything up for later. Okay, then we're going to divide both sides by 2, and y equals 3 over 2x minus 4. So what this layout does is it allows me to pull out two pieces of information that's going to immediately let me graph without creating a table of values. And what that's going to do here is this 3/2 is going to be my slope, okay, represented by the variable m, okay? And this negative 4 is going to give me my starting point. This is the value b, or more accurately, this is my y-intercept, so it's 0b, okay? So that does include the sign, by the way. So negative 4 means I'm starting at negative 4 on the y-axis, okay? So as I create my grid, let's get this ready, let's get this ready, all right? X, Y, arrow, arrow. Okay, so we're going to start at negative 4. So we're going to go down 1, 2, 3, 4. Okay, you'll notice I marked it in blue because that's where that number came from. Okay, that's that negative 4. And then what that slope 3 over 2 does is, remember, slope is rise over run. Okay, so we're going to start at the point that I just graphed and go up 1, 2, 3, and to the right 1, 2. And so right here at 2, negative 1, is my next point. Let's see here. So I used green. And so at this point, I can already connect my dots and make a line. But if I wanted one more for the sake of putting a third line on there to make sure that my ruler is not off or something, I can do the same thing. I can go up 1, 2, 3 to the right 2 and plot that point. And anything in that slope will be on that line. Okay? So again, that slope is rise over run. So we go up and then over. All right, does that make sense? What's up? Oh, no, I did. I messed that up. Okay, cool. Well, it all works provided you actually do it right. Erase that, and erase that. Okay. Thank you. All right. The mistake I made is right here. Whoops, I thought I was an eraser. Let's see here. Right here. When we divide both sides by 2, we have to divide the whole thing by 2. I accidentally left 4 alone. 4 divided by 2 is 2. So, my bad. All right, so provided you start there, we have right here, and then we do the slope, same idea, up 1, 2, 3, to the right 2, 1, 2, 3, 2. All right, this is the correct line once we connect the dots. Thank you for pointing that out. All right, so I can connect the dots. And label my line. I know this is an absolutely awful clash of colors. Nothing I can do about that. Notice that I'm labeling it with the original. I'm not labeling it with my slope-intercept form. I'm labeling it with what was given to me in the problem. Okay? And that's key. This is a 4, not a 21. In my defense, I'm writing on a slant, on a graph, with a digital pen. All right, so all right, let's move on to point slope form. And the whole reason for point slope form is to allow us to get to this easily. All right, give me just a second. All right, let's move on. So, point slope form's entire point is that given a point and slope, we can go through and find slope-intercept form, which allows it to be graphed really easily. Although, so does point slope, whatever. It allows us to find the equation of the line. There we go. Example 4.2f. We're told that we have m equals 2/3 and 0.3, 5. Okay? So we're given this information here, and we're asked to find the equation of the line. Well, obviously I don't have an intercept, so I can't just plug in. But instead, I can use my formula y minus y1 equals m times x minus x1. Okay, this should be vaguely familiar too. And then what we do is the ones with the subscript 1 are where our point goes. Okay, so y minus 5 is equal to 2/3 times x minus 3. I'm plugging in the values from the point into x1, y1. We treat the first point we're given as 0.1. Okay? Then at this point, we go through and distribute this 2/3 to everything inside the parentheses. So y minus 5 is equal to 2/3 x minus, and then the 3 cancels, 2. Add 5 to both sides. Yeah, that's right. Y equals 2/3 x plus 3. And that gets me to an equation for the line. Yes, I could have graphed the line with the given information. That would have been easy enough. But if we need the equation of the line, this is a quick, easy way to get to the equation of the line. And then we can manipulate it from there if we want. All right, so that was example F. In example G, let me go through and separate these. Okay. In example G, what happens, though, if instead of being given the slope and a point, I'm just given 2 points. Let's say the line is supposed to go through 4, 3, and -2, 2. Okay? And I'm going to real quick move myself out of the way here. Okay? Nothing like rearranging your scene live. All right. So we have these 2 points. Well, step 1 then is going to be to find the slope. So slope, remember, is equal to y2 minus y1 over x2 minus x1. And so then my slope is going to equal, well, y2 is 2 minus y1, which is 3. I'm taking and labeling this point as 0.2, this point as 0.1. That's not squared. That's me labeling it. Okay, and I always just do it in order. Okay, so I don't normally write the labels. I just go in order. And then my second x value is -2. My first x value is 4. Remember, the minus is part of the equation. All right, so 2 minus 3 is -1. -2 minus 4 is -6. Notice that gives me a positive 1/6. All right, so that now that I have my slope then, I can go through and use point slope form. Okay, now I usually just grab 0.1 for sake of avoiding confusion because the equation uses x1, y1. And if I was using that as x1, y1 in the slope, I'm going to use it in the equation. Okay, but you can use either point as long as you're consistent. So y minus y1 is equal to m times x minus x1. So y minus y1, which is 3, is equal to m, which is 1/6, times x minus x1, which is 4. All right, so y minus 3, I'm going to skip a line here. Y minus 3 then is equal to 1/6 x minus, that becomes 4/6, which is 2/3. What? Oh, the book used the other point, so I can't follow that math. Okay. I always grab the first point, though. So, all right, so then we're going to add 3 to both sides. And then I'm just going to keep in mind, in order to add fractions, we have to have a common denominator. Okay, so with that final thing, we're adding 3 to 2/3, so we need to make 3 something over 3. Well, to make something over 3, it would be 9/3. So 9/3 minus 2/3 is 7/3, so I get plus 7/3. Okay, so start at 7/3 and use a slope of 1/6 to get to my answer. All right, that is where we're going to leave off today. Tonight's work is practice 4.2, numbers 1 through, well, basically it's page 167 green. It's page 167 green. Do not go on to page 168. Okay, tonight is only page 167. We're not done with it. We're not done with the section, but that's enough to get started on those problems. And then we will finish 4.2 tomorrow. The remainder of 4.2's practice will be due Friday. Your quiz will be Friday over 4.1 and 4.2 as well. All right. Are there any questions? No? All right. I will see you guys later. Put this back before I forget. All right. And